So this is Algebra 1, Semester 1. It's a unit called Systems, and it's the 4th unit. And it's a lesson called Systems of Linear Inequalities Practice, and it's lesson number 5 within this unit of Systems. It's on creatormath.com under the Algebra 1 tab. You might have to Google creatormath.weebly.com to find it through Google. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So the notes can be a little bit difficult to find. So what I try to do on these videos is go ahead and look up the notes. Here's the actual website name. It's creatormath.weebly.com. Type that into Google, no spaces, and hopefully, if things work out right, you can find this homepage. Looks like this. So most students at some point in the semester have questions about the composition book, what goes in it, what goes where, etc. Scroll down under this picture here until you see the words composition book. Read all of these directions, watch all of these videos, adhere to these due dates, and put all these things on the right pages, as well as the notes, which we're going to get to when we click the next tab. So under the tab of the class you're in, or the video we're making in this case, you will find at least 5 things. They are the notes, the page numbers on which the notes go in the composition book, the practice sets like we're going to do here, the videos of the practice sets like we're making here, and of course one of the all famous, the PDF of the vocabulary we use throughout the school year. So if you're not getting 100% on your School G vocabulary practices, then you may not know there's a complete PDF of every word we're going to use throughout the school year that you can download to your device, and it's searchable. Just Google how do I search a PDF with whatever type of device you're using. All right, the instructions are a little bit different for each and every device, so just follow the directions they give you. Once you get to the tab of the class you're in, or the video we're making in this case, we're going to scroll to the appropriate semester. Right, for you, that's going to be the semester you're in. You will find the all-important table of contents, the TOC. The table of contents is to be written in its entirety on pages 2 through 6 of your composition book. It's about 3.5 pages long. It'll take you 30-40 minutes like me to write it in there, right? Why is it so important? Why do I want you to have that in that composition book? Because it maps out every page we're going to fill in throughout the semester. We're going to put very specific things on very specific pages, and without that table of contents, you're going to be lost. All right, so now once we've done that, we're going to navigate to the unit we're in. So this unit is Systems, and then see the lessons here, 1, 2, 3, 4, 5, 6, 7. There's 7 lessons under the unit of Systems. This is the 5th lesson we're looking at here, Systems of Linear Inequalities. Here are the page numbers on which the notes go. Please don't take this video's word for it, but go back and find the original table of contents. At the time you're viewing this, these page numbers probably will have changed. These are the notes. That is what is to be written on these pages, and we'll open that in a second. Here's the problems. That's the page we're going to do right now. And the video solutions that we're making right now will go into this link if everything works out right. So I'm going to open the notes. For me, it takes me twice sometimes. Knock on wood, it's never taken me more than 2 times, but oftentimes the first opening doesn't work. In this case, it did. All right, so you should be able to expand the notes. This is going to give you some problem sets to put into your notes and some description. It won't be perfect, but it's enough to get you started, and it will help you do the problem sets and the discussions that we have for this lesson. All right, so just to go over what they're giving us here, given a y is greater than or equal to x minus 3 and y is greater than negative 2x plus 4, what does the graph look like? What does the graph look? Where's the word like? What does the graph look like? Right here, right? So there's 2 things being graphed. If we go to the minus 3, 1, 2, 3, that's this right here. Then there's a slope of 1 over 1, so up 1 over 1, put 2 dots in a line. And this is greater than or equal to, so it's a solid line. The next equation is y is greater than negative 2x plus 4, so we're going up to 1, 2, 3, 4, putting a point here for the y-intercept. And then we're going down 2 over 1, down 1, 2 over 1, putting another point, and it's a dashed line connecting those. Why is it dashed? Because it's only greater than. It has to be greater than or equal to include the line. In this case, it's only greater than, so the values on the line are not included, and a dashed line represents that. Now, it's kind of interesting to read this, but you've got y is greater than or equal to this solid line, which is everything shaded above it, and you have y is greater than everything in this dashed line, so everything shaded above that. The combined shaded area is in between these right here, so it's called shaded area. Every value in this area now becomes a solution for both of these inequalities. So put these practice problems into your comp book. Write in the vocabulary, inequality is greater than or less than, and we also have greater than or equal to and less than or equal to. The shaded areas are the values there, and we're going to have some examples in the problem set. We're going to go to Desmos and type it in there and see how that helps us. And so for now, let's go into the problems and see how far we can get. So what is a system of inequalities? Okay, system. This is a word in math class and geometry and algebra you're going to see. So two inequalities on the same graph. And technically speaking, it's two or more. But what you saw were two graphs of two inequalities on the same Cartesian coordinate system right there, right? So that's what a system is. What's the solution to a system of inequalities? So the solution, if it was just two lines, you were looking for the intersection, that'd be a solution. It's a little bit different when it's an inequality. Now we're looking for the shared shaded region. So in the example in the notes, we had everything shaded above one line and everything shaded above the other. Well, the combined shaded region was this one here, right? That would be the set of solutions now for a system of inequalities. Given this, how is it read? This is a greater than. Given this, how is it read? This is a less than. And students mix it up, so we put it in there. That's greater than, that's less than. I'm not sure how you think of it, right? The large side over to the left would be greater than. The large side over to the right would be less than because the small side's now to the left. I don't know. I kind of forget how I learned it, but I know it now and it makes sense to me. So figure out a way. Given this one, how is it read? This is greater than or equal to. And some teachers do the whole thing of, you know, the larger side is an alligator and it wants to eat the bigger meal. So that's, you know, where the larger value goes. And that's fine. You can do any of that stuff, okay? Given less than or equal to, how is it read? Less than or equal to, okay? And that's two conditions. That's both less than and equal to. So if it were a graph, it'd be a solid line because it's got the equal to component. It represents all the values on the line. Number 7, on a graph, what does a solid line represent? All values on the line are included. So if you had that line like we had graphed, there was a line here and everything above it. We wanted a solid line if it's equals to, okay? Because it would include. Does it include this value? Yes, because it's on the line. A solid line represents that to us in graphing. On a graph, what does a dashed line mean? It means all the values on the line are not included. So if you had a dashed line here, right, and everything above it is included, say you had a point right on the line, is it included? No, because dashed line says it's not included. That would be a situation where it's greater than this rather than greater than or equal to. Okay, am I all the way on? Barely got everything. Using Desmos.com, what's the combined shaded area for these two given inequalities? Here they are here, and here's a graph. So I knew we'd get some practice on this. Let's see what we can do. Here, here, here. All right, let's type in y is greater than x plus 1. Okay, so y is greater than, here we go, x plus 1. All right, so notice that a greater than has a dashed line. So Desmos knows how to do it. Y is a greater than a dashed line because it's not greater than or equal to, it's only greater than. So if it's actually on the line, like these 2 points are on the line, they are not included in the solution set because we only want values that are greater than the line. Fair enough? All right, now let's type in the other one. It does have an equals, so what kind of line would you expect, solid or dashed? So because it's an equals, let's see what we get. So let's open up a new box here. We just tap. This one's less than or equal to, notice they've got the inequality symbols for us already laid out, minus 2x All right, the plus 4, so plus 4, okay? So let's move this here. And notice, so now here's the new line. Notice it's got an equals in it, so it is a solid line because the values on the line are included. And it's less than, so everything below this, right? It's below this. Now the less than here and the greater than here combine into this combined shaded region here. So looking at the graph on our answer sheet, that's this area here, which they're calling A. So area A, which is a combined shaded region of the two inequalities, would be the solution to our system of inequalities. Of the two graphed inequalities, y is greater than x plus 1 and y is less than negative 2x plus 4. Which inequality is represented by the dashed line below? Well, we just went through this. This is the two we just did. So now they're talking about a dashed line. It's got to be the one with just the greater than. Okay, so y is greater than x plus 1. It can't be the one with the equals. That's a solid line. And I have a feeling that's what they're going to ask me next. Which one is represented by the solid line? It's got to be the one with the equals in it. All right, so here's the solid line. So it's got to be y is less than or equal to negative 2x plus 4. Because y is less than or equal to, the values on the line the equals requires a solid line which includes the values on the line. Okay, so this one here. All right, using Desmos, what's the solution to these two? Okay, y is, I might as well just start over, it might be easier. Y is less than 4x minus 1. Y is less than 4x minus 1. Okay, did I get it right? Y is less than 4x minus 1. It's dashed because there's no equals. Y is greater than or equal to, y is greater than or equal to at negative x plus 9. Negative x plus 9. All right, so that's a solid line because it's got an equals in it. And so the combined shaded region is over here. So here's the combined shaded region, C. So C is which is a combination of the shaded regions of the two inequalities, right? Pretty easy, just type it into Desmos and let it show me what to do. But if you're looking at the whole thing, you know, if y is less than this one, right? So that's the shaded region. Y is less than this. So the shaded region below all this, less than, because less than is below. And see how it's slightly tilted that way? And then greater than this one, so everything above this. So this area here we don't care because it's not shared. This one we don't care, it's not shared. We care about this one because from these boundaries here, this is shaded for both of them. So the solutions work for both in this area alone. Okay, hence what the solution is for a system of inequalities. All right, what represents the dashed line? It's going to be the one with no equals. And that's just driving into our head that concept of the dashed line does not include the values on the line. Which one is the solid line? Okay, it's going to be the one with the equals, right? So that's just representing anything with an equal says it's got to be all the values on the line too. It looks like they're going to give us maybe one more example here. Let's try this. All right, so let's see here. Y is I'm going to just clear these. Just whoops. There we go. Y is less than x plus 1. Boom. And this one is y is greater than or equal to negative x minus 1. Okay, move this over so we can see it. So, you know, this is going to be the dashed line. This is going to be the solid line. That's what we've got. And the solution is the combined shaded region here. So it looks like C. So C is the combined shaded region. And remember, this would be a shaded region for the one function. This would be a shaded region for the other. But we want the combined shaded region because any solutions of x and y here are going to work in both of the inequalities. We'll make them both true statements. All right, which one is the dashed line? So the dashed line is the one with the greater than, or in this case less than, excuse me. But what I meant to say was no equals, right? A dashed line is the one without equals. And then which one is the solid line? So that's got to be the one with the equals, right? So y is greater than or equal to negative x minus 1. Check. And that's it. Just make sure that the title of this video matches up with the problem set you're doing, otherwise it won't make much sense. This is Algebra 1, Semester 1. It's the 4th unit called Systems, and it's the 5th lesson within that called Systems of Linear Inequalities Practice. It's on creatormath.com under the Algebra 1 tab. Hope this helps.